Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Now, today I'm going to be looking at reviewing this little FNIRSI. I know that's probably not how you pronounce the brand name. LCR-P1 transistor tester, they call it. This is basically an LCR meter. It's a bit like that kit version that I had a few years ago in the clear acrylic case. This is a bit more of a professional one, and it comes with a rechargeable battery, so you don't have to constantly replace 9-volt batteries by having to open up the case. Now, this thing's supposed to be able to test transistors like BJTs, MOSFETs, etc., resistors, capacitors, and inductors. And according to the specifications, we can test voltage regulator diodes from 0.01 to 4.5 volt or 0.01 to 32 volt. The capacitance range is 25 picofarad to 100 mF, little m. Now I'm assuming they mean millifarad, not microfarad. Resistor range is from 0.01 ohm to 50 megaohm. The inductance range is 10 microhenries to 1000 microhenries, which is okay. 10 microhenries is probably, for its lower limit, a little bit sparse. I would have liked it to go a little bit lower than that, but that's fine. So, also according to the description on eBay, and these are all over eBay, so they're not that hard to find, you get one tester, one instruction manual, one Type-C USB cable, one featured test plate, I'll get to that a little later, and 3 times test hooks. So, let's get the box open, and we'll have a look at what contents we've got here. So, if I can even get the thing open, it'd be nice. Now, I was hoping this was going to be a little bit bigger than it is, but it looks cute enough. There's the tester there, and that just comes out of the plastic tray. And this is the accessories underneath here in a little box. So, we open up the box. There is our instruction manual, which is in Chinese, so that's not very helpful to anyone. Oh, wait a minute. We've got some English here. Firmware update, at least the firmware update's in English. Operating instructions, parameter introduction. Okay, so the manual telling you about all the functions and stuff is in Chinese, which is not very helpful to anyone that doesn't read Chinese. And then, after they've gone through all the specifications and what things do what, it jumps into how to use the product in English. Alright, so I'll put that to the side. Here is the set of 3 test leads, which just plugs into here, into this gate. And the USB Type-C to USB-A type cable, which plugs in just up the top here. And when they said featured test plate, they're talking about this. This is a breakout SMD board, so you can actually test surface mount devices like Zener diodes, which would go over here, capacitors, resistors, as well as SOT transistor devices over here on this side. And the way that works is you can just pull this out, because it's only just plugged in with these headers. That one's a little bit how you doing. And then you'd plug this board in its place, like preferably the correct way round. I've actually got it upside down. It's a little bit how you doing, but there you go. And then you can test your SMD devices like that way. So I'm going to pull that back out because it's going to be probably a bastard to get it back out and in. So I'll put the original board back in. Okay, so I don't know if this has got any charge in it because I don't know how long it's been sitting around for. I assume you turn it on by pressing this button. There is one other feature here. We've got this switch, which currently it's set to the transistor position down here. You can switch it up to IR decoding for looking at infrared remotes. Now, I don't have a remote at the moment, but I'll think about that in a second. So I'm just going to push the power button and see if anything happens, or the test button. Well, it's loaded. But right away, I see no indication on the LCD display here of what our internal battery is doing. So I don't know if the battery is half charged, a third charged, or flat. So I guess what might be a good idea is, I don't know how long this cable is, probably short and useless. Oh yeah, about that long. Not great at all. I was going to say I was going to plug that into my charging board at the back of the desk, but it won't reach. So, okay. Well, I'm going to not do that. I've got to wait for that to finish now. I'm going to find some components to test, and that beeping is going to get annoying after a while. Long press and hold on the test button turns it back off. So I'm going to find some things to test, and nice. And we'll come back in just a second. Okay, I got a couple of PMP BC556 transistors here to test. Now, these came out of the long tail pair input stage of the MOSFET amplifier that wasn't working originally, so one of these transistors is suspect. So I'm going to take a brand new BC556 that's never been used, just as a control, and I'm going to just slightly bend the leads so that it'll fit into the socket. So when this paddles up, the gate's open. Close the gate, press the test button, and see what the result is. And there we go. Now, interestingly, this transistor is saying that it's got a HFE of 322, which is, okay. And the UBE is 662 millivolts. All right. So that's a good transistor. Let's try, well, it's a brand new one. Let's try one of the other suspect ones, if I can get it in the socket. Okay. And HFE is 188. There's a wild difference. All right, let's try the other one. And the HFE of this one's 120, so they're wildly different. So let me just get another working transistor just to make sure that everything's hunky-dory. 289. So we can see that there is wild differences between transistors. However, one of these two good ones aren't too far out from each other. That was 280 something. This is 300 and something. 319. All right, but this one here, if I can get it in the socket, because the leads are all bent and buggerized. This one here says it's only a HFE of 190. Now I'm going to say that this is the suspect transistor. So I'll put that to the side and I'll test the other one again. Hang on, that says 121 now. I don't think these transistors are any good, to be honest. Alright, so that's 189. So it was this one that's lower in HFE compared to the other one. So I already know ahead of time that one of these is electrically leaky between base and emitter, which is that one. That's the one that measures a HFE of 120. You should have absolutely no reading when you're in resistance mode with the negative probe on the base of a PNP transistor and the positive on the emitter. You should have nothing between base and collector either. If I could get the probes on there, it'd be nice. See, open load, that's what it should be. And you should also have nothing in the other direction, which the transistor decided to bugger off on me. As we can see, there is no resistance there, it's open load in the reverse direction of the probes. And you can confirm that with testing the other one with the negative on the base, positive on emitter, open load. So this transistor is faulty. Even though the part tester says it's still a transistor, well, it's electrically leaky, so that's the reason why the input stage was not working. Alright, but that's getting a little bit off topic. Let's get back to testing other components with this component tester. Alright, so I got a 330,000 microfarad capacitor, 20% tolerance, 63 volt. So I'm assuming that the tester says its capacitance range is 100 mF, which I'm assuming means 100,000 microfarad. So just make sure that the capacitor is discharged. And I'll connect one lead. I've got the test clips here that come with the meter. So I'll stick one there, the other one there across pins 1 and 2 of the tester. If I can get on there. That's good. Yeah. Let's try that again. There's too much solder on there, that's the problem. Right, that should do. I'll hit the test button. So as we see there, 3.4 mF or millifarad. So that's going to be 3,400 microfarad. So it's a little higher than its base capacitance. It's written on the side of the capacitor there. And it's saying its ESR is 0.14 ohm. So that's not too bad. The ESR is not high or anything. The ESR should always, for especially larger electrodes, be lower than 1 ohm. So that's perfectly fine. So I'll find another capacitor. So I got a 6,800 and the thing just turned off again. So I'll make sure this capacitor is discharged. And I'll connect one probe to positive and the other probe to the negative. Just long enough to test it. 6.2 millifarad or 6,200 microfarad. So yeah, ESR is 0.11 of an ohm. Yeah, these capacitors are probably not in the best of shape. But at least we know we can actually measure large filter electrodes with this little tool. So now let's try, say, a MOSFET. Just got a random MOSFET here, so it doesn't really matter which order I connect these test clips in, as long as they're connected. And like that. It turned off on me again, so I hit the test button. Well, it's saying it's a capacitor. Let me switch some leads around. Make sure that it's not polarized or something stupid like that. No, it still reckons it's a capacitor. Okay, so this thing is not really that great at testing MOSFETs. And just for clarity, you can test MOSFETs with this, but you've got to get the connection leads into the correct positions on the connector. For BJT transistors, it's the first 1, 2, 3 position. And for testing MOSFETs, JFETs and IGBTs, you go in the second set of 1, 2, 3 position here. I don't think it's really important which lead connects to what pin. And we hit the test button and let it do whatever it's doing. There we go. So it says it's a field effect transistor, a PEMOS, so it's a P channel. Pin 3 is the gate, which is correct, which is the red lead. Pin 1 is the drain, which is the black lead. And pin 2, which is the green lead, is the source. The gate capacitance is 671 picofarad, RDS is 1.4 ohms, and the VT is 429 millivolts. So yes, it can test MOSFETs, you just got to have it plugged into the correct positions on the tester. Just to verify that, I'm going to swap them back around to where they were, where I was getting capacitance readings. And just verify that it does have to be connected somewhere else. Well, now it actually is testing. Okay, well that's interesting. Maybe I've got my test leads the correct way around to test it or something. Or maybe it's just hit and miss. Who knows? A capacitance. So try again, see what happens. Yeah, it's hit and miss. So for a last test that I'm going to do with this, I'm going to connect it to a resistor. And when I say resistor, I mean a low value resistor. So this is a 0.33 100 watt resistor. So take one end and connect it to, well, that didn't work. All right, so I'll connect it to there. And the green one, I don't like these hookup wires. They're very stiff and not very flexible, which makes it annoying connecting to things. That's good enough. So I hit the test button. Right, it says it's a resistor, but its value is actually more like 0.6 of an ohm. But then again, this is a 20% tolerance component, I believe. So we know that the unit works. So I guess for completeness, I should test a Zener diode. So I'll take these leads out. I might put them back in. And I'll see what the IR decoding does. And I assume when you're testing Zeners, you press the Zener button and then hit the test. So I need to find a Zener diode somewhere, and it's connected across the test leads. Alright, so I've got a 15 volt 1 watt Zener here. Now it is specifically marked on the bottom of the case here KAA, so cathode has to go to this green wire which I've got in the K position, or else it probably won't test it correctly. Okay, turn it back on. Now I hit the Zener function, and I guess I just hit test. Alright, well that didn't really tell me much. Maybe because I'm plugged into the wrong things on the input here. I think I'm supposed to be plugged in down here. So let's try that again. There we go. So it says it's a voltage regulator diode, or Zener, with the voltage of 14.44 volts, which is pretty close to the 15 volt the Zener is supposed to be. Question is, will it work with the polarity of the diode reversed? So I'm just going to switch them round. Hit the test button again. Aha! Yes, it did actually test it, but it's saying that it's in the reverse insertion. So it knows that you've put it in backwards, because it's now voltage drop is 0.8 volt. So at least we know that function works. I can probably unplug that now. So that's a neat little tool there, I think. You just got to watch where you're inserting things. So for testing the Zener diodes, they have to be connected down the bottom section here. Otherwise it's not going to work. So I'm going to find a remote control from somewhere and see what the IR decoding function does. And I've got to figure out where you actually point it. Okay, I've got a remote, so I'll switch over to here. Now, I'm not sure where you point the thing. Maybe maybe at the top of the device. Oh, there we go. I mean, those codes are totally meaningless to me, but it's given me the idea and the indication that the remote that I've just pointed at the thing actually works. So I guess that's a good way of testing whether or not a remote control is working. So let me try that again. Don't think you need to press the test button or anything, so no, you don't. I'm just pushing random buttons here and it's giving me different codes. So it is actually telling me, I mean, the address code's not changing, which makes sense. The command code is, though. Isn't that neat? Cool. I like it. Very, very nice. So that's it for the FNIRSI LCR-P1. What do I think of it? Well, for the price, it's an alright tool. The inductance measuring value range is a little bit sparse for my liking. It would have been nice if it went down to something below 1 microhenry. Other than that, the capacitance range testing is pretty good, so it can test up to 100,000 microfarad. The Zener diode function works. I haven't tested the SMD breakout board because I don't have any SMD components, but I'm assuming that it'll work the same as just inserting normal through-hole components into this gate here. And for the price, you can't complain. So if you want one of these, just type in FNIRSI, FNIRSI, LCR-P1 into Amazon. I don't trust Amazon, but Amazon, eBay, places like that, even AliExpress, I guess. Bang good. And it will probably come up. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya. Thanks for watching. Have a great day.